Let's learn together. I'm your host George. In this video tutorial, we will continue where we left off in the last video. And what we had was a program that was printing a message that had a $sign character in it. And now let's print the same message using only service 2, one character at a time. So how do we go about doing that? Let's open up another EMU 8086. I'm going to close the previous one emulator, and I'm just going to copy this and put it in this other emulator, and I'm going to delete these two backslashes, and instead I'll say MSG1 DB, and here's our message. Now, to print this using only service 2, I'm going to copy that part of this program and paste it over here at the bottom. To do this, what we can do is load the effective address of this message into SI register. For example, we could use SI, DI, or BP. So I'm going to use SI. Load into SI, MSG1. And then we can move the character. So what this does is puts the offset of this letter I in SI. So now we can move that into DL. We can say move into DL what SI is pointing to by enclosing it in square brackets. So this will put the letter I in DL. And then we can create a loop. Let's call it loop 1. And all we have to do is, since we have the letter in DL, we can call print character to print that letter for us. So let's give it a try. Single click, load SI into DL. This is DL right there. Letter I is loaded there. It's 49H in hexadecimal, and now print it. It jumps down here to print the letter I is printed, and then it returns where there's no other instruction after the call print character, so it goes to the end of the program. So now let's continue with this. Once we have it printed, what we could do is increment SI, right, and move it into DL again, just like so, and then we'll loop L1. Now let's single click through it again. Okay, so the first instruction loaded the offset of message 1 into SI, which is 102, and as you can see, if I click on message 1 highlighted, it starts at address 102 right there. So that's loaded into SI register. Now we're going to move the character that the SI is pointing to in memory into DL register, which is 49. Now we can call print. It does its job, this function, and returns to the next instruction, increment SI. So SI is pointing to the first letter. Once we increment it to 103, it's going to point to the space, which is shown right here. 102, 103 is the space, SPA, which is 20 hex in hexadecimal. If I click on next, you'll see 20 hex in DL register. Next, 20 hex moved into DL register. Now we're going to say just loop again, loop L1. So that's going to go back to call print character. It's going to print that character, which is a space, which you will not see anything. And then come back and increment SI to 104 to point to the next letter, load it into DL, loop print, and it's going to call print character again, print the third character, and come back, and is printed as you can see down here, and come back and keep on doing this until the end. Well, how far does it go? Let's run it. As you can see, it's printing everything, and it continues printing afterward because it does not know when to stop. So we have to give it a counter. We have to put something in CX register to tell it how many letters to print, how many characters. So a way of doing that would be if I go under the variable MSG1 and I type length equal, I'll say $ minus MSG1. Now I can put that in CX register. Right over here before the loop, I'll say move into CX length. If I run this program now, emulate and run it, as you can see, it prints everything along with the $ character. So to reduce the CX by 1, we can add to the length variable over here -1 to it, so it does not print the $. I'm going to run it again. Boom, it's printed as expected, but see the difference between printing a character and printing a string. Printing with using Service 9 is much faster. Look at that. Boom, it comes up right away. You don't even see it printing one character at a time. As opposed to printing using Service 2 only, you can see it struggling to print everything slower. So let's take a look at how this program works. I'm going to click on Emulate again and go single step through it. So first we're loading again the effective address of our message 1 into SI, which we agreed was 102. 102 is loaded. Then load what SI is pointing to into DL, which is 49. And then length into CX. Now notice CX has a number in it already, which is going to be overwritten. If I click next, it loads 1D. That's the result of this directive right here. And I'm going to explain that in a minute. Now, we're going to call print character, which will jump to this function, print character, and print that character and return, right? So it returns to the next instruction, which is increment SI. Size 102. Currently, it'll be 103, which points to the next character in our message. It's just a space after the I letter. And move that into DL. DL now has 20 hex space and loop 1. Once I click on single step, notice that CX will be decremented. Here you go. And now we're going to call print again to print that space. And it jumps to the print function, prints the space, and returns. Increment SI again. SI now pointing to 104. Load that into DL. DL now has 6E, which is letter N. Loop again will decrement CX again. CX is decremented to 1B. So if I run it all the way to the end, CX will be 0. Once it's down to 0, the program ends. So what we're doing here with this directive is basically telling the assembler to calculate the length for us by, and let me show you how that works. If I click on emulate and click on message, it'll be highlighted over here, and you can see the start of the message is at 102 offset, and the end of the message is at 11F. Let me do this first. I'm gonna delete this -1 first from here, and then repeat what we did. Single step, move length into CX. It gives me 1E. What happened is it subtracts the end of the message, $, which is 11F, but in reality it goes one step further to 120 and it subtracts that from 102. So basically, if you had like 2-3 variables over here, messages, what this does is tells the assembler to subtract the start of the second message from the start of the first message. That's how it works. So let me click on calculator and we'll subtract 120 from 102. So let's go to hexadecimal. 120 minus 102 equals 180. That's what we got over here. So if we do minus 1, then we'll subtract another 1 from it. As you can see, let's run it again. Single step, length into CX. Now we have 1D. That is 120 minus 102 and minus 1 again equals 1D. That's how this directive works. I want to mention that this is a very powerful feature of the assembler, which you can do a lot of things with. For example, I could divide this by 2. If I divide it by 2, it lands somewhere in the middle of your message or your variable. Or I could also do this, for example, end of message equals $sign minus 2. This lands me at the last character in my message, which is a period. If I want to print this message in reverse order, what I could do is, instead of loading message 1 into SI over here, I can simply say load end of MSG message into SI. Keep everything the same except for, instead of incrementing over here, we will decrement SI. So we're going to start from here. We print this letter, then decrement SI, print the next one, and then the next one, and then the next one, and so on. Let's give it a try. Emulate and run. As you can see, it printed the message in reverse order. So this gives me end of message into SI. As you can see, it gives me 11E. And if I look at the message itself and scroll down, you'll see 11E points to the period at the end of message. So even though this is a nifty feature of the assembler, it only deals with addresses in memory or offsets in memory. It does not deal with values contained within these addresses. So anything you do, it only points, whatever name you put in, it only points to addresses or offsets in your message or variable. We've come to the end of another video tutorial. I hope you enjoyed it. Please take a moment to like, maybe subscribe, comment, or share with your colleagues or friends to help with the algorithm for this channel. And I hope to see you soon in the next video. Goodbye.